Okay. So we're not going to cover very much today. Just kind of the basics. And you probably already know this, but organic is its own separate branch of chemistry. If any of you go on to major in chemistry, biology, do anything with medicine or biomedical engineering, you're going to have to take a year-long course of this. And I'm not going to lie,
It's hard.
it's death, okay? But you might be one of those people that it just makes sense to you. I mean, there are basically two types of people who take organic. Those who get it, and those who have to memorize their way through. I was one of the ones who had to memorize my way through. Some people don't have to do any of that. It just, like, makes sense to them. You might be one of those people, okay? What we are going to talk about is just the very basics of, like, how to draw organic molecules, how to name them, and just a little bit into the reactions, so that if any of you do go on to take organic in college, you will have some semblance of what's happening for maybe the first week or two. After that, I got nothing. Okay, so we're talking about, so all the word organic means, organic just means we're talking about carbon-containing compounds, okay? Why do they get their own branch of chemistry? Because they behave very differently than inorganic compounds, okay? And mostly we're going to be dealing with a class of molecules called hydrocarbons, which is exactly what it sounds like. Things with hydrogen and carbon. And the first family of hydrocarbons that we're going to look at are called alkanes. Okay? And this is the general formula for an alkane. Don't memorize it. Okay? An alkane is just a chain of carbons all linked together with single bonds, and in every available spot that you can put one, there is a hydrogen bonded to it. That's an alkane, and if you draw that out, for however many carbons there are, there will be twice as many hydrogens plus 2 more. But again, don't memorize that. It's just a chain of carbons all connected with single bonds. And you need to know this word, saturated. And we hear this word a lot when talking about, like, fats, saturated fat, unsaturated fat. The word saturated in terms of organic compounds means all single bonds. Okay. And the reason that the word saturated is used, because if you think about what that word means, saturated means like full, can't hold anymore. So what are we talking about? Full of what? Full of hydrogens. That every available place there is a hydrogen. So that's why they use the term saturated. Okay? And fats are just long carbon chains. That's all fats are. Okay? So what if it's not all single bonds? Then it would be unsaturated. Okay? And it can be a double bond, it can be a triple bond. It only has to be one multiple bond. If there is a multiple bond somewhere in the carbon chain, it is considered to be unsaturated. Okay? This is a word we saw on the AP exam, isomers, and a lot of you came back and said, what's an isomer? Well, now I'm going to tell you. Okay? An isomer is when you have two molecules that have the same number of atoms and the same types of atoms. So both of these have 4 carbons, 10 hydrogens, but look at their arrangement. Okay? Butane has 4 carbons connected in a row, basically. Whereas isobutane has those 4 carbons connected in like a T shape. And for any of you that go on to study biology or chemistry in college, you're going to just learn more and more that all chemistry comes down to shape. things react the way they do, react at the rate that they do. Reactions are endo versus exothermic based upon the shape of the molecules. Shape is everything. If you change the shape, you change the molecule. Okay, the chemistry of butane versus the chemistry of isobutane is very different. Okay, but they are isomers. Same number of atoms, but a different arrangement. And we're going to get into naming today. Okay. The first thing you want to do, if you are given a drawing of an organic compound, and I say name it, the first thing you want to do is find how many carbons are in your longest chain. And based upon that number is going to give you sort of the base of that name, okay? And see if you remember. What are the prefixes for 1, 2, 3, and 4 carbons? Do you remember? Meth, eth, prop, bute. Meth, eth, prop, bute. And then after that it makes sense. It's the Greek prefixes. What's 5? Pent. Hex, with an H. Hept. Oct, non, dec. We're not going to go above 10. Okay? And then if you'll notice, since it's all single bonds, that means it is an alkane, so it gets that ane ending. This is hexane. Okay? And then to take it to one notch higher in complexity, you can start attaching things onto that main chain of carbons. And if you have something attached to your main chain, that attachment has a fancy name. It's called an alkyl substituent. Okay? It just means something attached to the main chain. For example, let's say to this hexane I attach 2 carbons to that 3rd carbon in the ring. Okay? So what you want to do, just like in the main chain, is ask yourself how many carbons are in that substituent. 2. What's the prefix for 2 carbons? F. Okay, but I don't call it ethane hexane. Substituents get this YL ending, so I don't call it ethane, I call it ethyl. That's what's called an ethyl group. Okay. So the name of this molecule would be, and I'll get into this other part in just a second, 3-ethyl hexane, all one word. Anybody want to guess what that 3 is referring to?
It's attached to the 3rd carbon.
Correct. That ethyl group is attached to carbon number 1, 2, 3 on my main chain. Okay? So if it's a substituent, it gets this YL ending. Okay, let's look at another example. Okay. Again, first thing you need to do, you're given a structure and asked to name it, is figure out where is your longest chain of carbons. And guys, that's not always going to be in a nice straight line. This one, it just so happens, is, but, I mean, your main chain could be in an L shape, and like this would be my substituent. Now that's not the case because 4 carbons is not my longest chain. Okay, this could be my longest chain, but is it?
No.
No, because that's 5 carbons. My longest chain here is 6. Okay? Now that's a substituent. What would you call that substituent? Methyl. Methyl. 1 carbon, methyl. Alright? And there's its name. Now, somebody yesterday asked the question, when you're deciding what to put for that number, the number of where the substituent is attached, do you always number your carbons from left to right? No, you don't. You number them so that the substituent is joined to the lowest number carbon you can. So it would be incorrect to number from right to left, because then it would be on carbon number 4. And if I number from left to right, I can make it on carbon number 3. So you number your main chain whichever way is going to give you the lower numbers. Okay. And then what if you have more than one substituent group? Like, what if I had this? There. Okay. First of all, I've changed the picture. So how many carbons are in the longest chain that you can see there?
6.
It's still 6. Okay, it's still 6. Okay, now the next thing we need to do is name our substituents. How would you name this one? Okay, methyl. How would you name this one? Ethyl. Okay. Does numbering left to right, is that still better than numbering right to left in this example? Yes. Okay. Right, and from here, we're ready to write out the name, and it says that you list them, you write them in alphabetical order. What comes first in the alphabet, E or M? E. So here's the name. 3 ethyl, 2 methyl hexane. All one word. Okay. Anytime you're writing a name and you're transitioning between a number and a letter, you put a dash. But if you're just going letter to letter, you just push it all together as one word. Let me change the situation another way. What if I do this? Okay. Are 6 carbons still the longest chain?
Yeah.
Okay. This is a methyl group. This is also a methyl group. Anybody want to guess how we name it?
2, 3 dimethyl.
Very good. 2, 3 dimethyl. Di meaning 2. Dimethyl hexane. If you had 3, you could call it trimethyl. Okay? So I'm going to give you some practice with this. And here's what I'm going to ask you to do. It says name and draw the 5 isomers of the alkane C6H14. Well, the simplest way to arrange these would just be 6 carbons in a row. And for now, guys, it's okay with me if you just want to draw that carbon backbone. You don't, just for now, it's okay with me if you don't fill in all the hydrogens. But if we did, there would be 14. Okay. How would you name this molecule? Hexane. And that is isomer number 1. Now this is sort of a puzzle situation here. Okay. In order to find the remaining 4, this is how I would suggest you start out. 6 carbons in a row is our basic chain. My suggestion to you on trying the next isomer is don't make a chain of 6 carbons. Make a chain of 5 carbons and start using that 6th one as an attachment, as a substituent. Okay? And see what kind of arrangements you can come up with. Okay, it does say name them, but what I'm going to do is just walk around and help you guys work through coming up with these isomers. Once you've found the 5, then go back and name them. Don't try to name them as you go. Okay? Try it. Yes, you do have to put 2, 2, as silly as that seems. That is correct. Okay, this time I'm going to give you a name and I want you to draw it. We're going the other way. Try this one. Now my recommendation, when you're given a name and asked to draw it, work backwards. Start with the longest chain and then start attaching things to it. Nice and easy. So, any questions so far? Okay, good. This slide, I'm just going to skip for now. I'm going to come back to it next week. Okay. A couple of you, I was walking around, and you were drawing your isomers. Some of you were trying to connect the carbons into like squares, like connecting 4 carbons together. And it's not that those molecules don't exist, but in what we were just doing, if you had done that and then drew in all the hydrogens, you'd find that your hydrogen count did not come up to be 14, which is what it was supposed to be. But there are molecules that are not carbon chains, but are actually carbon rings or shapes. Okay, so for example, if you have 3 carbons, not in a line, but in a shape, oops, wrong color. It's a triangle. Now each carbon has 2 hydrogens coming off of it. Okay, that's cyclopropane. That's how you distinguish between it being just a chain of carbons or in a shape. Okay, what's a shape that has 4 sides? Very good. A rhombus. Okay? So there's cyclobutane. Okay? And just like chains of carbons, you can join things to them, substituent-wise. Okay? So I'm going to have you do these, but we're going to do number 1 together, just so you understand the process. First things first, just like we were doing before, we need to find our longest chain of carbons, although it's a little different here. How many carbons are in the cyclic shape? 6. Each corner represents a carbon. So what's the prefix for 6?
Hex.
Hex. And they're all single bonds, so hexane. But they're in a circuit, so cyclohexane. Okay, that's the base of the name here. Now let's deal with these guys. These are substituents. If the hydrogens are making you nervous, then ignore them. How many carbons do you see here? 2. What's the prefix for 2? Eth.
S.
And it's a substituent, so ethyl.
How do you know what?
Alright, in this one, how many carbons do you see?
3.
What's the prefix for 3?
Pro.
Prop. Okay, now that's, and I'm going to tell you this one because you wouldn't know this otherwise. You might think this is propyl. It's actually not. It is called isopropyl, and I'll tell you why. Let me show you what propyl would look like. Can you see what the difference is? I mean, ignoring the hydrogens, can you tell me what makes these things different? Why is this propyl and this is something else?
Oh, I know.
Why?
Because no.
2 of the carbons have 3 hydrogens in the phosphorus.
The hydrogen count would be the same. Think about where that substituent is linked up to the main shape.
Oh, it's
from the
at the
middle.
end.
Okay.
That was what I was going to say,
It's-
but I didn't think it mattered.
No, that does matter. Shape is everything.
The end.
Okay, propyl, this would be propyl because it's just joined on the end carbon, 3 in a row. Isopropyl because it's joined in the middle. Okay, this is just one that I'm telling you because you wouldn't otherwise know it. Now, just like we've done before, let's think about how we want to number the carbons in this shape. What comes first in the alphabet, E or I? E. So how about if we make this carbon number 1? Does it make sense to number counterclockwise or clockwise? Why?
Isopropyl would be 2.
Yeah, that'll give you collectively lower numbers. So this is going to be 1 ethyl, 2 isopropyl cyclohexane, all one word.
Oh my god.
Okay. Now, before we go on, I just want to say one thing. The next time you are in your shower, I want you to start reading the back of your shampoo bottles. You're going to see compounds that look like this. The next time you take a vitamin or, take Advil or anything, go and look at the ingredient list on the back. You will see a lot of compounds that look like this, with numbers and letters and dashes and all that, and now you'll know what those mean. Try the rest of these on your own. Notice that dimethyl was put before ethyl. D comes before E in the alphabet. And that's where we're going to stop.